The cosmic microwave background radiation, reimagined by augmented Newtonian dynamics. When we look into the universe, we see light from stars, galaxies, and nebulae. We see the glow of supernovae, the fire of quasars, the arcs of galaxies bent by gravity. But most of the cosmos is invisible. The spaces between galaxies are dark, and to our eyes, they seem almost empty. What we cannot see is the silent ocean of radiation that washes through all of space, the cosmic microwave background, or CMBR. Discovered in 1965, this radiation does not come from stars or galaxies. It arrives equally from every direction, with a temperature of just 2.7 degrees above absolute zero, a near-perfect blackbody glow that peaks in the microwave band. Satellites such as COBE, WMAP, and Planck have measured it in extraordinary detail, mapping faint ripples only 1 part in 100,000. For half a century, it has been hailed as the afterglow of the Big Bang. But is it truly a relic from a cosmic fireball, or is it something more subtle, a living radiation field, born continuously in the great voids of intergalactic space? A new reinterpretation of the cosmic microwave background becomes possible with the introduction of augmented Newtonian dynamics theory, which brings 2 key concepts into physics. First, it assigns a real physical structure to the photon, a massless particle, electrically neutral, yet capable of both carrying charge and delivering energy. Second, it restores the concept of photon frequency as a physical property. This redefinition of photon frequency is essential if physics is to keep pace with modern technology. The older treatment, where frequency is used merely as an abstract mathematical device to calculate photon energy, is no longer sufficient. Nor is the traditional reliance on spontaneous emission, imagined as a delayed and random release of energy. In the age of nanosecond switching and terahertz systems, such abstractions cannot capture the fantastic speeds at which both photons and our technologies operate. And theory prefers that photons be described in physical, not merely mathematical, terms. This is a much-needed rethink of the whole of atomic structure. Quantum theory describes photons as fluctuations, excitations of an abstract electromagnetic field. But this idea carries serious difficulties. If a photon is nothing more than a field excitation spread across space, how can it also be said to originate from a single electron at the instant of emission? And if it is extended everywhere as it travels, how can it then be absorbed discretely by one electron alone? These contradictions lie at the heart of the standard picture. They force us to accept that the photon is both local and non-local, both particle and wave, depending on the experiment. Augmented Newtonian dynamics avoids this paradox by giving the photon a real, physical structure, one that can be emitted in a directed line from an electron, travel through the photon ether, and be absorbed in the same precise, one-to-one fashion in which it was emitted. A key advance of augmented Newtonian dynamics is that it gives the photon a real physical structure with exact dimensions. According to this conception, the photon can be directly emitted and absorbed by a single electron without paradox. In this framework, the familiar notion of wavelength is reinterpreted as an abstract temporal measure, not a literal spatial length. For radio and microwaves, the physical dimensions of the wave train are large enough to be measured and related directly to size. But at optical energies, photons are so closely related in frequency and energy that a single-dimensional model can be applied to all of them. In AND theory, the photon has a diameter of about 10 to the power of -16 meters, while its length varies with energy. Yet the precise length is to some extent irrelevant. What matters is the electron's ability to emit and absorb such photons with ease. This new structure also explains how, using this new paradigm, electrons can emit an almost infinite range of photon energies, and, crucially, do so in timescales of femtoseconds. This new perception puts the electron in charge of the energy it needs to mediate. The photon is no longer a mathematical abstraction but a real, physical entity with definite dimensions, fully compatible with the remarkable speed and versatility of modern physics and technology. According to augmented Newtonian dynamics, when an electron needs to shed energy, it does so through the emission of a sequence of discrete pulses of electric energy. These pulses add up precisely to the amount of energy the electron must release. The first pulses are the strongest, and each successive pulse is slightly weaker. This natural progression creates a polarity between the leading and trailing edges of the pulse train, producing a stable configuration that behaves as an electric dipole. After forming the photon, it is immediately emitted. No question of storing photons, they are made and dispensed on demand. In augmented Newtonian dynamics, the old quantum mechanics idea of spontaneous emission is abandoned. The picture of an electron passively absorbing a photon and making a mysterious quantum leap to a new energy level is set aside. In its place, AND theory describes a bound electron as actively self-regulating its energy by constantly emitting and absorbing photons in a process of self-interaction. This is similar to the way in which the nucleus stabilizes itself through the constant exchange of massless gauge particles called gluons. In this framework, the bound electron's motion is direct and physical. It absorbs a photon, travels inward, and bounces off the nucleus, which, being about 2,000 times more massive than the electron, serves as an immensely smooth, flat-sounding board. Scattering experiments, from Rutherford's gold-foil experiment to modern electron diffraction, confirm that the nucleus behaves as an overwhelmingly massive target relative to the electron, fully consistent with this picture. Like a billiard ball striking a cushion, the electron recoils, its trajectory obeying a simple geometry: angle of incidence equals angle of reflection. When the electron reaches the proper energy level, it re-emits a photon, recoiling again and retracing its path to absorb the next photon. This cycle repeats at breathtaking speeds, hundreds of trillions of times per second, providing a continuous, physical mechanism for atomic stability without recourse to the abstract idea of spontaneous emission. This process of absorption and emission of photons by the electron explains the rectilinear nature of light, it explains why light follows the inverse square law, and it explains reflection itself, all without resorting to a single abstraction or esoteric explanation. Now that we have understood the AND theory explanation of photon creation, emission, and propagation, we can return to the problem of studying the cosmic microwave background radiation. Almost 90% by volume of the universe is made up of deep space with a very low density of 2 to 3 particles or less per cubic meter. However, observations show that just as the Earth is constantly being bombarded by radiation of all types coming from all directions, so too must the isolated individual particles of deep space be bombarded almost constantly by all kinds of radiation. Deep space is incredibly empty. Estimates vary from a density of 1 particle per cubic meter to 2 to 3 particles per cubic meter. For this reason, modern astrophysicists have discounted the idea of these isolated atoms being able to emit any kind of meaningful radiation and have dismissed the idea of any radiation emerging from these unbelievably large tracts of near-empty space. Instead of present-day radiation, modern astrophysicists have opted to view the detected background radiation as relic radiation left over from the Big Bang. From a purely ontological point of view, this is highly unsatisfactory. AND introduces a new theory for the origins of the cosmic microwave background. Imagine an isolated hydrogen atom in deep space. Even in that thin darkness, just a few atoms per cubic meter, the atom is not inert. Hydrogen is selective. It responds at its allowed frequencies, most strongly in the Lyman series, ultraviolet. Each allowed interaction triggers a response. The electron in the hydrogen atom absorbs and emits these photons at the rate of 451 times 10 to the power of 14 photons per second, sending out a line of identical connected photons that travel through the virtual photon ether, dark matter, that fills the universe. Now scale this up. There are unimaginably many such atoms, everywhere, in every direction. Individually, these are lines, but across cosmic distances they overlap and blend into a smooth, nearly thermal glow. The radiation from any one event dilutes with distance, inverse square, but the number of emitters grows with volume, so the integrated sky never falls silent. In this view, the microwave background is not fossil light from a one-time flash. It is the living murmur of hydrogen, continuously renewed by allowed transitions and guided in propagation.